Welcome in and thank you for joining us today. We're going to be looking at the icons of depth and complexity as they apply to a chemistry lesson. I'll introduce that lesson and go through a little bit of the background, talk about those icons of depth that we'll be using in this lesson, ultimately the lesson arc and how that contributes to that, the differentiation strategies we'll use, as well as the assessment and the cultural and language supports. In today's classroom, we always have students working towards achieving a certain standard. So all lessons are based on what we ultimately want them to learn. In this case, we're looking at the standard HSPS1-8. That's a physical science standard, and it's to develop a model to illustrate the changes in the composition of the nucleus of an atom and the energy released during the process of fission, fusion, and radioactive decay. Now, as you can see, that's a rather complex topic. And in fact, that one standard cannot be done in a single lesson. So what we do is we come up with a storyline to anchor our understanding. We call this an anchoring phenomenon. In this case, when we're talking about fission and fusion in stars, we might want to introduce what do we even know about this process in the first place? Do students know that there are stars? Do they know what stars are made of? And importantly, by then they likely will have heard that stars are made of hydrogen, but one thing they might not consider is, if that's true, then why are stars different colors? To answer that, well, it'll demand quite a bit of in-depth, complex understanding. In order to reach the depth and complexity of knowledge expected for the standard, we are going to use the icons of depth and complexity offered by Kaplan. In particular, there are 8 icons of depth and 3 icons of complexity. We'll focus in on the following: the patterns. What patterns are we seeing? What trends might be there? Are the stars the same color? If the answer is no, why might that be the case? And can we find a reason for that? Is there underlying patterns? And in particular, are there underlying rules that might give us that information? Can we make a prediction with that information? Are there any unanswered questions? At this point, through this lesson, there will still be unanswered questions like, why are those stars different colors? Even if there are different things in there, ultimately, what's producing that light? That gets into the question of radiation, fusion, fission, and touches at the very deepest heart of what chemistry really is about. When using the icons of depth and complexity, it's important to explicitly have students state them and identify what they're doing. In this case, our goals are to identify stable patterns. That's at the bottom of our Bloom's taxonomy. Then we're going to derive governing rules and then develop or create a model that shows that understanding. Our goal here is to go from fairly simple to much more deep and complex understanding. Before you get started, it's often important to know where students are at so that we can make sure that each one of them is growing appropriately. In order to do that, a quick pre-assessment on the material you've already covered could do the trick. Doing that, you might allow them to do the most difficult ones first, and if you check and their work looks good, well, then they can skip straight to the activity of developing that model, showing process of nuclear fusion and fission as a fun escape room activity, showing how an atom might decay and release different types of particles that escape. Students work directly with the concepts the icons represent. In this case, for patterns, they're looking for ratios of proton to neutrons that make matter stable or unstable. They're also looking for other types of patterns that might exist. What makes a molecule neutral? What makes an atom neutral? What's the difference between one isotope and another? Is it the mass? Is it the proton count? Is it the number of electrons? These are all important things that students will need to understand in order to know what rules are the underlying principles determining what makes matter stable and what makes matter decay. Ultimately, there'll still be unanswered questions that we'll reflect on at the end. It's important for students to reflect on their learning so that they understand what they in fact did learn and what they still need to know. When using anchoring phenomena, it's often the case that what we end up doing takes several days to complete. In this case, we might need to spot those patterns on one day and generalize the rules on the next, and then build that model on the third. Finally showcase and reflect it on a 4th day. Taking a look at the slide here, finding patterns on the right using a simulation. Technology is vital for students to interact with because it's in their everyday lives and it's a useful tool in the classroom. Just like an anchoring phenomenon anchors the content, we could use these icons to anchor the process. For example, if you're talking about the patterns and focusing on the patterns, it'd be very helpful to show the patterns icon so students realize that that's what we're doing at that stage. Going with that, once we've worked through the patterns and identified some, now it's time to look at the deeper rules. Switching up the icons show that we're actually doing a different intellectual process. Now, the primary goal in this case is for all learners to build that atomic escape room where they can show their knowledge of protons and neutrons and decay. However, there are alternative options. If you were to tier the instruction, you might want to switch it up using multiple intelligences as well as Bloom's taxonomy of thinking. Going with that, you could use a product choice chart to create other options, such as making a podcast about the information, creating a different type of animation other than the escape room, creating an infographic, or many other options. The important thing about that is whatever you're doing, make sure that you tier that instruction so that you have at least 3 different tools to use for grading. Our ultimate goal is to make sure that students not only understand the content, but can relate that content to themselves and to their everyday life. Going with that, technology can be a strong asset for you in the classroom if there's someone who's having some trouble with the language you're using. Some features like Google Meets or Engagely offer live captions as well as live translations. That's very helpful for people who are not familiar with the language you're using. Making sure that that content is absolutely relevant is most critical for students to retain that information. For example, if you talk about radon poisoning and the isotope and the radiation from that, you'll discover that there's quite a bit in Oregon, and you could look at charts and graphs related to that. That brings it directly to their home and questions, do I have radon here? Other things could be like nuclear waste and the problems we're facing with that, with the various disasters that have happened over the past decades, as well as archaeological dating of important artifacts, things that may be culturally relevant to those students you have. So it's really important to make sure that when you're introducing examples that they be relevant to your specific population. To recap, whenever you're teaching anything in alignment with the standards you're teaching, you could still dive much deeper into the material and into greater complexity by using the icons of depth and complexity. In addition to that, you could combine other strategies such as the anchoring phenomenon discussed, as well as the tiered instruction to add extra layers of depth and complexity so you could meet your learners wherever they're at. Thank you so much and have a great day.